So we're looking at algebra, and the thing with algebra is we're going to have some changes in how we represent things. A big area is in multiplication. So we're used to seeing stuff like 3 times 5. But now we're going to represent it a little differently. You're going to see this dot. You might have seen me use this before. You're also going to see other ways of representing multiplication. You might see something like this. That also means multiplication. This also means multiplication. And so does this. So in algebra, for various reasons, multiplication gets symbolized a lot of different ways. Another thing that comes up in algebra, and we're going to talk about this today, variables. When you see a number next to a letter like this, it's usually x. This means 3 times x. In algebra, we call it really a strong interest in efficiency. We try not to have to write these multiplication signs in. And then if you see 2 variables next to each other, say an x and a y, that's x times y. So any questions about that? All right. Now, another use that's a little different in algebra, but not totally, is with parentheses. And we're going to talk about how to get rid of parentheses without having to do computations like PEMDAS. And this is going to be important because we're going to have variables. And variables are unknown numbers. They're mystery numbers inside parentheses. Well, how do you do a calculation if a number is mysterious? So that's something that we're going to take a look at. So oftentimes with parentheses, you'll see something like this. And a way to think of this is like we're dealing with 2 separate quantities. So we don't know exactly what the parenthesis, what's inside it, is actually going to mean until someone identifies x for us. Until x is identified, the internal part of these parentheses are mysterious. So all we can say is we have a first quantity minus a second quantity. Here, I'm going to do something like this. So first quantity minus that second quantity there, just running out of space. Now, another thing in algebra where things start to change a bit is division. So we're familiar with long division. We divide 48 by 2, and this is the same as 48 divided by 2. But you're also going to see division written as a fraction. And we've talked about this before, that division and fractions mean the same thing. So this could be 48 halves, or it could mean 48 divided by 2. Also, you'll see it written like this sometimes. That can also mean division in algebra. So questions about that? Now, for both multiplication and division, you'll be asked sometimes to translate. So you might see something, for example, like this. 8 times 7x plus 2. And what we're going to do, we're going to replace the 8 with that algebra of times. But then we're going to actually, again, get rid of the multiplication sign. If we have something in parentheses, like 5 times 3, you don't have to put the multiplication sign there. You can just leave it like that. So you'll see this kind of way of expressing multiplication. Same is going to be true with the division. And if I'm erasing too fast, let me know. Eight divided by 7x plus 2. Well, again, what this is going to mean, we could use that for division. The algebra symbol for division. But typically what we're going to do is we're going to use the fraction. And you'll see this a lot. When they put a fraction like this, they'll oftentimes drop the parentheses. So you'll get something like that. So questions about that? So those are some of the language differences with algebra versus arithmetic. Now, the big thing with algebra are variables. Now, variables, and this is all that they are. They're unknown numbers. So you can think of a variable as a big mystery box. Something that we wish we knew what this number was. We just don't know what it is. Now, oftentimes, well, I gotta be careful saying often. Sometimes we can guess the value of a variable. So in a way, a lot of this is just a big guessing game. I mean, let's say if you're a fan of Lord of the Rings, for example, if you know the story of the Hobbit, you fall down the it's not trolls, goblins. That's what the that's goblins that are in the Hobbit, and then they become orcs later on. But anyway, you fall down the goblin hole, down you go, and you run into Gollum. and Gollum's down there, and he won't let you go home till you answer a riddle. In fact, it's 3 riddles. Well, actually, just keep going and going until you get one wrong, is basically what happens. And these are basically going to be mathematical riddles. So let me show you what I mean. So some number plus 2 is 7. So what we want to answer is, what is the mystery number? And this is algebra. That's all algebra is. Can we figure out the mystery number? Well, you could guess a few, like maybe if you try 3, well, if it's 3, 3 plus 2, ooh, that's equal to 5, not 7. But if you play around with it, you'll eventually get this has to be equal to 5 since 5 plus 2 equals 7. And that's all a variable is. It's a mystery number. And what happens here and what's it's equal to, that gives us a clue as to what that mystery number is. So the study of algebra is really just answering these types of riddles. Can we figure out the mystery number? And it turns out some of these riddles can be pretty hard. So that's why we're going to learn all these little tricks to answer what this mystery number is, to figure it out. So for reasons that I could only guess, we usually don't represent mystery numbers little boxes like that. We usually don't do that. What we usually do, and my guessing for this is that it's a historical thing. This gets tiresome to write all the time. So what they did, you can come up with a letter, something very simple to write, a very simple symbol that's easy to write, and it doesn't look like any numbers. So we often use X instead. Now, again, I'm guessing as to why X has been chosen, but I can give you 2 reasons. One, it's easier to write. And 2, it doesn't look like a number. Adjust that little camera there. So that's what X is. It's just a mystery number. It's a number we use it to represent a number we don't know. So what we'll do, we'll take this riddle and we'll make it into X plus 2 equals 7. All right. So that's all that algebra is. So the techniques for guessing are what we're going to cover towards the end of this chapter. But what we're going to get into now is, well, if we've got these mystery numbers, what if somebody gave us permission to choose values for them? And when we have something like that, it's called an algebraic expression. So we choose, we don't have to guess. We choose values for our variables. So, for example, well, we're going to choose some values for these variables, for x and for y. So, I don't know, let's let x equal 7 and y equal 3. So when we do that, our 3x plus y becomes 3 times 7 plus 3, or 21 plus 3, or 24. So questions about that? We'll do another one. But here we get to choose the value for x and y. We don't guess it. Again, if I'm going too fast, let me know. So x is 0 and y is -5. So that means our 3x plus y will now become 3 times 0, because remember, a number next to a variable means multiplication, plus -5, or 0 plus -5, and that's just going to be -5. Questions about that? All right. So just some terminology with expressions. So what we tend to do is we have terms, and these are separated by plus or minus. So for example, we see something like this. Plus in there. These are 3 terms. Now, another thing that comes up are factors. Now, factors are 2 or more things multiplied together. Here, I just want to double check, make sure I'm using the definition they're going to want you to use. So multiplied quantities. So for example, these are 3 factors. And you could technically argue if you wanted. This 4x, this 4 times x, are really 2 factors and not 1. You could say that as well. So any questions about this? So next, we're going to take a step up with our algebraic expressions. We're going to talk about formulas. And what we do with the formula is we take the value of an algebraic expression and assign it, or just give it, as the value of another variable. Or put another way, this another variable, its value is going to depend on what happens with the value of the algebraic expression. So this another variable is just sort of waiting. It's going to discover its value once we've decided on the value of the algebraic expression. So let's say we have something like this. A equals B plus C. So what we need to do here is this. First, choose values for B and for C. So you got to choose those values first. Second, we add those values because we're supposed to add B plus C. And then the sum is the value of A. So let's let B equal 2 and C equal to 10. Well, then A, which is B plus C, well, now this is going to be equal to 2 plus 10. And 2 plus 10 is 12, so that means A is equal to 12. Questions about that? Now let's say we do something a little more complicated. Let's say T equals 4 times B minus 2F. I don't know, it's some crazy formula. But here's the thing. We won't be able to know anything about T until we choose B, we choose F, and do the math. So let's just say B was 20 and F was 6. Let's do that. So we're going to replace B with 20, replace F with 6. Now this is called substitution. And here we replace a variable with a number. So that's what we're doing when we replace these variables like B and C in the last example, or B and F in this example. That's called substitution. So we have our equation. And now we do the substitution. We have 4 times. B was chosen to be 20. And remember, a number next to a variable means multiplication. So this is 2 times 6. So you have t equals 4 times 20 minus 12. Now we're going to follow PEMDAS. So do what's in the parentheses first. T equals 4 times 20 minus 12 is 8. And here's that algebra, another symbolism for multiplication. For a number, there's some parentheses. So you have 4 times 8. That's what that means. And 4 times 8 is 32. So questions about that? All right. So those are some of the uses of formulas. Now there's a special set of formulas that they want you to go over. I'm going to go over those too. There's 2 in particular, 2 sets. And one has to do with speed, and the other has to do with temperature. And we've actually encountered the temperature one a little bit before, but we're going to see it again. And it's the proper way. I want to be careful. I should be careful using the word proper. Converting between Celsius and Fahrenheit. But first, let's take a look at some special formulas, which are distance, time, and rate. Now, we ran into this a little bit with conversions, like miles per hour, and then we want to convert to maybe kilometers per hour, things like that. But the idea is going to be this. Distance divided by time, and again, we use that fraction bar to represent division. That's your rate of travel. Or put another way, distance over time is equal to rate. Now there are 2 other versions of this formula. So I want to list them out. We have our first one. Distance over time equals rate. We also have distance or time times rate equals distance. And then the third one is time is distance divided by rate. So you actually have 3 of these. Each one solves for a different property. So for example, find the rate if distance is 400 miles. And the time, let's see, is 8 hours. So in this case, we're looking for a rate. So if we're looking for the rate, we're going to use this formula. And we're going to substitute a distance of 400, a time of 8 hours, and that's going to give us 50. And we have miles over hours. That's that 50 miles per hour. But when we're looking for a rate, we're going to use that formula. Now let's try another one. Those are 3 formulas to choose from. So for this next one, let's say we have this. How long does it take to travel 1,000 miles driving at 50 miles per hour? So how long does it take to travel 1,000 miles driving 50 miles per hour? But we're looking for time. When they ask how long does it take, they're talking about time. So we're going to use time is distance over rate. Or in this case, 1,000 miles over 50 miles per hour. And we're going to get time as an answer. Turns out it's going to be 20 hours, because again, this is 1,000 divided by 50. And that's going to give you 20 or 20 hours. Questions about that? Now, you might be wondering, how did I get hours to magically pop out like this? I would ask that question. So I'm going to get into some detail here. But if we take our 1,000 miles, 50 miles per hour is 50 miles per 1 hour. That's what 50 miles per hour means. Now this again in algebra means division. So this is 1,000 miles divided by 50 miles over 1 hour. This is fraction division. So we can put that invisible 1 underneath our 1,000 miles. So the way we divide fractions is we do KFC. Keep, flip, change. So we keep the 1,000 miles. We flip this. We change this, and we'll use the algebra multiplication, the dot. Now, if you remember from our conversions chapter, miles on top and miles on the bottom means those cancel out. So you get 1,000 over 1 times 1 hour over 50. Multiply across, you'll get 1,000 hours divided by 50, and that's going to be 20 hours. Now, what you can also say is that with this formula, if you use it correctly, you're always going to get a time for an answer. But if you want to get into kind of the details of why that's true, this is the reason why. So lastly, take a look at this. How far can you drive at while driving 50 miles per hour for 6 hours? Well, here we're asking about distance. So we're going to use that formula for distance. And distance is time times rate, or rate times time. You could switch the order on these. Now, in this case, our time is 6 hours. And our rate, again, they're next to each other, so that means multiplication, is 50 miles per hour, or 6 hours. And we can convert this again to 50 miles per 1 hour. And once again, you see hours in the top and in the bottom. They're going to cancel. And we can treat this as fraction multiplication. There's a 1 under there. So multiplying across, we'll get 300 miles over 1. And then dividing by 1 doesn't change anything. 300 miles. So questions about that? All right. So that's the relationship with distance, time, and rate. Now we're going to take a look again at those temperature ones. Let's take a look. So when we looked at the conversions chapter, we used a chart. But I also showed you there's a way you can use a formula too. So degrees Celsius, if you know the degrees Fahrenheit, you can use this formula to convert it to Celsius. So let me do a little research here. So let's look at the temperature. in Roswell. So the current temperature is 62 degrees. So if it's 62 degrees right now, and that's Fahrenheit, what is Celsius? So again, we're going to substitute this F with 62. We'll find out what the current temperature is in Celsius. So here's our equation, or our formula. Now we replace the F with the 62. (62 minus 32 is 30. 5 times 30 is 150. And dividing this by 9, let's see. Grab my little calculator here, it's disappeared. We'll get 50 over 3. And we'll give an approximation to this. So it's approximately 16.7 degrees Celsius. So if you step outside right now, it's going to be 62 degrees Fahrenheit, 16.7 degrees Celsius. Questions about that? Now, there's another formula going the other direction. And this is where we go Celsius to Fahrenheit. So what we're going to do here is this. You may have heard that water boils at 100 degrees Celsius. We want to find degrees Fahrenheit. So when you hear water boils at 100 degrees, that isn't 100 degrees Fahrenheit. 100 degrees Fahrenheit is how hot it gets in Roswell, say, or in summertime, or Phoenix gets like 120 something. We're going to replace the C with 100. No, it's 100 degrees Celsius. So let's find out what that is in Fahrenheit. Now this is 900 divided by 5. That's 180. When we add these together, we get 212 degrees Fahrenheit. So when you hear that water boils at 100 degrees, what they mean is degrees Celsius, or 212 degrees Fahrenheit. All right. So that's the introduction to formulas, algebraic expressions, variables, and some of the language of algebra. So what we're going to look at next, we're going to start talking about the riddle side of algebra. And the riddle side of algebra this is where you're trying to find or identify a missing number. You're trying to figure out what that missing number is. And this is really what most of the algebra classes you're going to run into, beginning algebra, advanced algebra, college algebra. That's what these are going to be about. How do we answer that riddle? And we're going to start out with some we're going to call it equations. And you heard me use that word earlier. And equations are really kind of like a balanced scale. And what we're going to do is going to use the fact that equations must be balanced in order to solve for that missing number. We're going to use the fact that they're supposed to be balanced. So first off, we're going to talk about some ideas, though. Well, we'll get into equations. We're going to skip around a little bit. We're going to jump into section 7.3. We'll get back to 7.2. Well, all right, we'll go in order. We won't skip around. So what we're going to be looking at is a little more work with algebraic expressions. And what we're doing here mostly is the idea of what's called combining like terms, or what you'll hear sometimes called simplification. And the idea of simplification is we're going to take really complicated expressions, and when solving for unknown numbers or variables, this is going to be one of the things we need to do first. It's just going to make our lives much, much easier. And it's also going to give us an introduction to some ideas what we're going to call distribution. So what I'm going to call this is simplification. And the first thing of simplification we're going to talk about are like terms. So what are like terms? Well, we talked about what terms are briefly. These are expressions separated by pluses and minuses. They're sort of islands, really, with pluses and minuses in between. And like terms, these have the same variable or variables and the same corresponding exponents to those variables. So let me give you an idea of what this looks like. So like terms have the same variables and the same corresponding exponents to those variables. Better give some examples. So let's review terms. We'll take a look at terms again. I mean, this is a new thing, so this is all going to be still kind of strange. But for example, these are three terms. And they're separated by plus or minus. So you have three terms separated by plus or minus. Now we want to talk about this idea of like terms. So what are like terms? Well, they have to have, a term has to have the same variable as the other term and the same exponents. So these are totally different terms. So this is an x squared term, an xy term, and a type constant term. So even though there are x's here, this one has an extra y, and this one doesn't have the square. So that means these are two different terms. So let's play around with identifying like terms. So let's take a look at this. 7x squared. And there's something I'm kind of leaving out here. I'll explain it in just a bit. Well, I'll explain it now. The number in front, we call this a coefficient. But this number in front, we can ignore that. It's only the variable and the exponents that matter. So this is a type x squared. Now let's look at some terms. So let's say we have 3x squared y negative 4x squared 9xy and 37. Well, are any of these the same type as this? Well, this one here, the variable's an x squared and a y. So this is a type x squared y. So it's not the same type. And again, we can ignore the number in the front. I mean, it's close. There's an x squared, but that extra y, that changes things. Now this one is a type xy and not a type x squared. No luck with that. When there are no variables attached, this is called a type constant. Ooh, squeeze in constant. So there's one left, and this is the one that's the like term. And this one, again, we ignore the number in front. This is the type x squared. So questions about that? All right. So let's do some more like terms. So let's say we have this. And these are the ones we get to choose from. And 41. So let's take a look at these in terms of type. Again, just looking at the variables and their exponents. We ignore the number in front. This is type x squared y cubed. Now this one has an x and a y. I'll give this one a variable. Let's call it x squared. But it's just x and y without exponents. So it's not the same type as that. Now this one is darn close. It's x cubed y squared. So it's got the right variables. It even has sort of the right exponents, but they're not corresponding. They're not corresponding to the correct variables. The 3 needs to be on the 2, and the 2 needs to be on the x. Oh, I'm sorry. The 3 needs to be on the y. The 2 needs to be on the x, like this. So this won't work either. This one is a type x squared. It's halfway there. We do have an x squared, but we're missing the y cubed. Not going to work. We look at this one, it's a type, and again, we ignore the number in front, x squared y cubed. That's it, they're the same type. So this is the like term. Questions about that? So the last thing to mention, this is the last thing I'll mention tonight. Once we're okay identifying like terms, and it takes practice, we can combine them. So let me do an example. Let's say we have this. So what we can do, if we look at these in terms of types, well, this is an x squared. This is a y squared. That's an x squared. And this is a type y squared. So what we can basically ask is this. How many of each type is there? Well, if we take a look at the x squares, type x square, we have 4 of those and 3 of these. So we can say there's 4 plus 3 x squares, or 7 x squares. And there's 8 plus 4 y squares. So I'm skipping some steps here. We're going to get into what I'm doing here. We have 12 y squares. We'll talk about this in a bit. But just so if you wanted to get ahead in the homework, the formula you would use is something like this. And for our final answer, we're going to leave it in a summed form. Now, I'm skipping a lot of steps. We're going to go over those on Tuesday. We'll talk about those on Tuesday. And because I want to explain, how did I get to this from up here? And there's something I want to show you. And we'll talk about that when we get back together on Tuesday. So I'm going to have to cut it a couple minutes early because I just don't think we'll be able to give our subject the proper treatment that it deserves. So just to give you an update, what we're going to do, and less than a minute to go, we're going to, I'm going to send out tomorrow night a pretest. This is a study guide. Basically, it's all the possible questions, or topically speaking, the types of topics I could ask you on the test. We're going to do a test on Thursday, and I'll get that out to you by Friday evening. And then we're going to continue on. And we're going to try to get through chapter 7 and chapter 10. We'll look at some trigonometry, get some trigonometry subjects in here. So that's the plan. Any questions, let me know. Again, the grade book's been updated, so check that out. And if you have any questions, let me know. Other than that, have a wonderful evening.